Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Smart Control Strategies for Power System Stability, Dynamic PID Controller Tuning via Hybrid Optimization Algorithm. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the applications that we have designed to tune the PID controller, which is useful in many of the domains in the electrical and as well as for the industrial and many other applications. So here the optimization algorithm has been proposed, which is tuning the PID and making it dynamic. So let's move to the video. Before moving to the video, in the domain of power system, we will see that what we will cover into it. We will discuss about what are the application areas where this can be implemented or can be useful. Then whatever the code is designed, how to execute it, what are the files and what are the software requirements to execute that will be there. Then we will talk about what were the current systems, what are the problems identified in them, and exactly what is implemented in the proposed system. Finally, the experimental outcomes and findings will be discussed. So let's move to the application areas. So PID controllers are not restricted in any specific area. It is useful in many of the domain. Either it can be for the chemical processing, for the power generation system, for the manufacturing domains, and many other areas. The PID controllers are useful. So they are basically the control units. Those are used to furtherly control the applications. So the general formulation that we use to get is here. Here the factors Kp, Ki, and Kd. These are the factors those are impacting the outcome and need to be tuned. So on that inspiration from that, we are basically moving to the code. So you will get the code like this, under which there is a folder named code and having all the files which we have developed. So the every code is implemented in the MATLAB, so you must have the MATLAB software with you. The MATLAB version that I'm using currently is R2019A. You can use 2015 also, but there is slightly variation among the files that I will let you know later on. As you can see, we do have the same folders files for 15B as well as for the 19. So the both are having the same name, only are exported for the 15 also. If you want to use the MATLAB version for the lighter version, you need to run these files, else 2019 or 18 they will run with this one. So in order to run the code, you just need to copy the path. Here right click, copy, go to the MATLAB, paste it here and press enter. When you will press enter, you can see all the files can be seen here. Out of this, we do have different files that you need to run. Two of the files are this optimize PID, another one is optimize PSD MFO PSO, right? So in order to get the results, these are the modules that we have designed with the optimization algorithm. This is with the proposed optimization algorithm, and if we need to run the normal PID and the fuzzy PID, then we do have the different models. This is for the normal PID model, which do not need any code file. You just need to open it and you can just execute it in the Simulink. So when you will just open it, there is nothing that you need to input from the code. You just need to click on this run and it will be ready to show you the outcomes, right? So as you can see, if I'm going to run it, it will process the model and the results can be seen on this scope where different parameters has been analyzed. So you can see the parameters that we were getting are, the scope will be shown. So it is giving us the system outcomes. So here you can see two of the graphs are with us, right? So out of which these are basically for the, one is the controller response, another one is the system response. So this is the controller and this is the system response. This is for the normal PID without any tuning or any control model with it. Second model is this one, main mode, which is the fuzzy model, fuzzy controlled model, which is predefined KP, KI and KD values that is given by us. So here the KP, KID value are taken from this fuzzy systems which we have designed by following the reference paper. So these are the fuzzy file KP, KI, KD which are generated by us. So you can design it by writing the fuzzy over here. When you will write fuzzy and press enter, you can see the fuzzy logic designer will be open. So you can create it by your own also, else I'm going to show you that what exactly we have designed. I'm opening the KP. So you can select the fuzzy file, open it. It will show you it is having two factor, delta W and delta W naught. This is the change in the W, this is the W, and then these are the rules that are defined in order to get the KP value, and this is the membership function for the KP, which is varying from 0 -3 to 3. And for input function you can see it is -6 to 6, and change in delta is all 0 to 1, because obviously the variation will be like that. So you can adjust the factors and each and every range as per your as per your requirement. So you just need to select it and you can just define the range from lower range, upper range, and this can be designed from a fresh file also. So we have designed 3 of the files which I told you that how you need to open. So how we have designed it, now let's talk about that. Before that, I told you in order to run the code uh, for the normal PID, this model is to be run. If you are working with the 2015 MATLAB, then you need to run this one. So I'm currently using 2019, so I'm running this one. For fuzzy based model, you need to run this. If you want to run same in the 2015 version, run this one. Do not run this one, run this file, right? Because that is a C file, configuration file only. Now, other than that, two of the models are there. One is Optim OPT main model SLX. So which we have called in the PSO based application in the fitness function. So the function that we are using here is fitness. So you can see the file name fitness. Here it is. So here the model name written is OPT main mod. So if you are using 2015, you need to make a change here. In place of OPT main mod, you need to write OPT main mode 15B. So this model name you need to give here. And for the proposed one, the file name is mfitness and the model name is OPT main mode MOF. So you, if you are using 2015, you need to write 15B at the end, right? So this is how it will be start executing and give you the results. So I'm clicking on one of the files. So whatever, these two files are executable. So in for two cases, normal and fuzzy, direct model can be executed. For the optimization models with the PSO and the proposed technique, you need to run this file and this file. So firstly I'm going to run this. In the meantime, let's talk about that what exactly we are doing. So you can see uh, when I just clicked on the run, it start running. It will take some time because it is uh, processing the code at the local, then going to the Simulink, then processing the results and getting it from the fitness function and extracting out rise time, setting time, overshoot, ESS, and on that behalf the fitness is being calculated. Now let's talk about what exactly we have done. So we have followed this base paper in which they have designed the fuzzy PID control system. So they were getting the PID better by using the fuzzy system. So what we have identified, that they have proposed certain methods by using the optimization algorithms in order to tune the PID. So optimal parameter of the conventional methods are managed by using the TLBO, PSO, two of the method, TLBO and PSO. So inspired from it, we identified that the optimization algorithm can play an important role in tuning the PID and making it dynamic. But the PSO and TLB algorithms were traditional and having few drawbacks. So from the simulation, we came out with the things that PSO is better when it compared with the TLBO. So obviously we need to modify the PSO itself. So when we have searched, we came to know that the PSO particle swarm optimization algorithm is facing the issues like get stuck in the local optima while exploring the new solutions. So we decided to update it by changing the PSO's internal functionality by introducing the concept of Moth flame optimization algorithm, which is termed as MFO optimization, right? So it the capability of this particular method was that it was not getting stuck in the local optima. It is better in exploring the new solutions. So inspired from that theory what we have identified, we have merged the exploration capability of MFO to the PSO and replace the traditional PSO with that. So you can see that what exactly we have implemented. In this PSO, we were implemented the whole PSO method. In the proposed, we have given the proposed PSO and MFO hybridization. So let the one iteration to be closed, so that I will pause the code and show you the results directly, because it will take so much time. So it will take few more seconds so that I can show you one of the iteration, because in the optimization algorithm, every time it generates a set of kp, ki, kd and then fed those values to the model, and model will be simulated for 10 seconds and then give you the factors those that I already told. So this sim function simulate this model with the factor kp, ki, kd which we got from the optimization algorithm, and then simulate the model for 0, minimum of 0 and maximum to 10 seconds, and give us the outcome in the terms of factors from which we do extract rise time, setting time, overshoot and ess. So on that we calculated the fitness, which should be better. So in this one, you can see once the simulation will be closed, I will show you that how these factors get automatically taken from here. So when this particular both of the files, any of these two files will be executed, these factors are set to be global. It means the model will have these variable name. They will check its simulation that whether there is these variables existing or not. If these are existing, they will take these values and process the model, right? So it is taking too much time. So here you can see one of the iteration is being done. So this was the fitness which was calculated by using this concept. So I'm just pausing it now and quitting it, because it will take so much time and we need to understand each and every concept of it. So I'm just quitting the debug part, and then here after that we will see the model. Then I will show you how they are taking the values from the simulation. Control C is the shortcut key to stop the simulation, right? So I'm showing you the model. Firstly, the PSO one, here it is. So when I'm opening it, you can see this model will have, where in the previous models, the fuzzy system that we were introducing here, we were not giving any additional parameters. So when you will double click on the model, you can see here only these things were there. Those were using those fuzzy files which I already shown you. But here 3 more parameters are added to these outcomes so that PID get tuned. So these factors will be taken from the code itself, right? So this is what exactly is happening in the second one. So here you can see this is the modified one. Its fuzzy will have 3 variables termed as mkp, mki, mkid. As now the values and did not simulated, so it is showing me red, but when the code will be executing, it will show me the outcome. So finally the convergence come and other factors will be shown. So I will show you the results directly, because we have written the paper for that. So you can see the results for the normal PID were like this, where we basically need to reduce these variations. So you can see from the normal PID it was like this. When a fuzzy was introduced, this get reduced, but there was still fluctuation. When the PSO based tuning is being done with the fuzzy PID, it get more reduced with respect to the normal fuzzy. And finally with the proposed one, you can see I'm just minimizing it, so you can see the range of the fluctuation get reduced, which is much better. So overall results from the proposed method get better, where we have introduced the concept of PSO MFO optimization algorithm to tune the PID parameters. So further modifications are still possible. For that you can contact us directly. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.